All right, this is lesson 1.5 for our Precalculus 12 class. The lesson, or the unit, is called Functions and Transformations. The unit is called Horizontal and Vertical Translations. In this lesson, we're going to talk about what is a translation, and we're going to learn how to read horizontal and vertical translations from function notation. And apparently I cannot spell from. So translations. A transformation is a function, a transformation of a function alters the equation and thus alters the shape or position of a graph of a function. So if I have for example, if I have an absolute value function, the graph would be a v, and a transformation is something that alters the shape of that v, whether it smushes, like compresses it, or stretches it, or if it's something that moves it up, down, left, right, flips it over, flips it upside down. Any of those kind of things would count as a transformation. Now, a translation is a specific type of transformation. It's one that moves the shape of a graph up, down, left, right, but does not change the actual shape itself, just moves it. So if we have in black, we have the parent function, absolute value of x. We can move it to the right, like you see in red. We can move it down, like you see in green. We can move it right and down, like you see in purple. To do all those things without changing the shape, that would be a translation. Okay, so I know it's a little bit messy here on this slide, but let's talk about horizontal translations. Horizontal translations are we move a shape left or right. We're going to use h in our function notation as our placeholder for the value of the horizontal translation. The notation right here is, in general, we have f of x, some function, is equal to x minus h. And so let's unpack this a little bit. Notice that the minus h is inside the brackets. That means that when we plug in an input for x, we put a number in there. The first thing we're going to do is subtract h from that number. So that means we're altering the input of this function. When we alter the input like this, we're doing a horizontal transformation. All right, so let's unpack this and understand it by looking back at our parent function for absolute value. So we're going to say f of x is the absolute value of x. That's our parent function. And we can graph it right here on this black line. If we plug in 0 as our x value, 0 is our input, absolute value is 0 is 0, so 0 is also the output. 0, 0 is on the graph. If we use 1 as an input, absolute value of 1 is positive 1, 1 is our output. If we use 2 as an input, we get 2 as an output, or the absolute value of 2 is 2. If we plug in 3, the absolute value of 3 is 3, so we get a positive 3 as an output. So we got this line right here. Now if we plug in any negative number as our input, we're going to take the absolute value, it's going to make the negative positive. So the absolute value of negative 1 is positive 1. Absolute value of negative 2 is positive 2. So the input for negative 1 is positive 1, and the input for negative 2, the output's going to be positive 2. Negative 3 is the input, 3 is the output. So we have our line over here, which completes our V shape for our parent function, and this is the graph of our parent function in black. Now, g of x in red, we're adding 1 to x, and it's inside the absolute value symbols. So this is going to count as a function transformation. H, we get h when we have x minus h, but we have x plus 1. So that means if we rearrange plus 1, we can get a minus sign out of there. So subtracting negative 1 is the same thing as adding plus 1. So this is mathematically equivalent, saying the absolute value of x minus negative 1 is the same as the absolute value of x plus 1. So we're going to write this right here, and so our h value is negative 1. So when I read function notation, I know that this means we're going 1 unit to the left. H value is negative 1, we're going 1 to the left. And we can verify that by drawing a quick table. So down at the bottom here, I've got a quick table for g of x. If I use 0 as an input, I'm doing the absolute value of 0 plus 1. So then 0 plus 1 is 1, absolute value of 1 is 1, so the output would be 1. Input 0, output's 1. So 0, 1 on my graph is right here. If I use an input of 1 into g of x, g of 1 would give us 2. Our output is 2. So 1, 2 is a point on that line. I throw in an input of 2. The absolute value of 2 plus 1 is 3. So 3 is our output, 2, 3. So we got this line. If we go to the left, we can throw in, let's see, negative 1 is our input. We get the absolute value of 0, which is 0, so that's this point. We throw in a negative 2, the absolute value of negative 2 plus 1, or the absolute value of negative 1 is positive 1. So that's where we go back up. And we can see that we're creating this v right here, and this v looks like the same shape as the parent function. It's just translated or shifted 1 to the left. And so we can see this does in fact shift the whole function graph 1 unit left. So that matches our h value. Now for h of x, the blue function, we have the absolute value of x minus 2. Okay, and so this does match our setup, x minus h, so 2 is our h value. So our h is 2, so we're going to be moving 2 units to the right. And we can verify that with another table. We can throw our inputs for x, and we get our outputs for h of x. If I throw in negative 2, I'm doing the absolute value of negative 2 minus 2, or the absolute value of negative 4, which is positive 4. So negative 2, 4 is up here. I throw in negative 1, my output is 3. I throw in 0, my output is 2. I throw in 1, my output is 1. And I throw in 2, my output is 0. And I end up creating this line. And I know if I keep going, I'm going to start going back up. And so we've created the same V shape, but it's translated 2 units to the right. Okay, so basically, if we get to this step, whatever we add or subtract to our input is going to be a horizontal translation. If h is a negative number or less than 0, as in the red equation, we're moving to the left. If h is a positive number, or, such as in the blue function, h of x, I know we're subtracting 2, but if we fit our model here, subtracting h, subtracting 2, 2 is h. So if h is positive, we're moving to the right. This one is counterintuitive. So if people are going to mess up, they're going to get that backwards. So pay close attention. All right, that's horizontal translations. Now we're going to talk about vertical translations. Notice the notation here. F of x equals x plus k, and the plus k is outside of the brackets. The h, the minus h was inside the brackets, but the plus k is outside. So what we're doing is we're taking our input value, and at the very end we're adding a constant value, k, to it. This is going to result in a vertical translation, so it's going to shift the whole graph up or down. So we start with our parent function, f of x equals the absolute value of x. We get the v shape, and we take k of x, which is the absolute value of x, and then plus 1. We can create our quick table. Negative 1 is an input. We get the absolute value of that is positive 1. Add 1 to it, we get 2. 0 plus 1 is 1. 1 plus 1 is 2. And so we're creating this v up here. Same shape, just translated up 1 unit. Plus 1, so 1's our key value, going up 1 unit. We can add p of x to this table. So if I use negative 1 as an input for p of x, it's going to spit out an answer, an output of negative 1. Because the absolute value of negative 1 is positive 1, and positive 1 minus 2 is negative 1. If you use 0 as an input for p of x, p of 0 is going to result in negative 2. And then we throw in 1 as an input for x, or for p. Oh, I think I got in the way. P of 1 is going to be negative 1. So 1, negative 1 is a point on our graph. And we can see we're creating this v that's 2 units translated 2 units down. Same shape, just move down. And so what we see here is that if we have plus k, and k is some positive number, we go up, and if k is some negative number, we go down. Unlike horizontal transformations, this one's a little more intuitive. Plus means up, minus means down. Okay. All right, we just looked at 4 different examples of transformations that are translations of our parent function in the absolute value. So g of x and h of x are both horizontal translations. K of x and p of x are both vertical translations. G of x is going to be 1 unit to the left. H of x is 2 units to the right. K of x is 1 unit up, and p of x is 2 units down. I probably should have wrote that in here, but I didn't. I'm sorry. All right, so let's branch out to some other parent functions here. In general, our transformations look like this. X minus h is our input. In our input is going to be the horizontal translation, and the plus k is going to be the vertical translation. For a, we have x plus 5 inside the absolute values. So that's 5 units to the left. We have minus 1 at the end, so it's down 1. B, we have x minus 5, so we're going right 5 units. And then minus 3, so we're going down 3. Now the next ones are radical functions. So the parent function is the square root of x. We're subtracting 1 inside the radical. So that means we're going to go, that's our h value is 1. So we're going to go 1 unit to the right. Our k value is 7, so we're going 7 up. In D, there's no adding or subtracting inside the radicand to the x. So there's no horizontal translation on D. We do have a minus 2, so our k value is negative 2. So we're going down 2 units. For E, we have a third root function. Our input's being added 2, so our h value is negative 2. We're going left 2 units. Our k value is positive 3, so we're going up 3. The next 2 examples, f and g, are both examples of exponential functions. The exponent is where the x is, and so there's a plus 1 also in the exponent. So that plus 1 is going to tell us that we have an h value of negative 1. So that's our h right there. So we're going left 1 unit, and then we have minus 2 at the end, so we're going down 2. K is negative 2. Example G, our h value is 5, because that's the number in the exponent with the x minus 5. So we're going right 5 units. And then k value is 1, so we're going up 1. H is a little confusing for the h value, but if you look at I and j, you can see that the h value for I is positive 6, and the h value for j is negative 4. That's why they move right 6 and they move left 4, respectively. And so there is no brackets around the x, so that just means that we aren't adding or subtracting anything to our input initially. So we don't have a horizontal translation at all. All right, but we do have a plus 1, so our k value is 1, we do go up 1 unit. I also has a plus 1, so the k value is 1, up 1 unit. And j has a k value of negative 5, so we're going down 5 units. Now, if I were to improve this list of examples, I would include an example that doesn't have a vertical translation. See, D and H, those 2 examples only have a vertical translation, and they don't have a horizontal translation. But I don't have any examples on this list that are just horizontal. So, for a fun exercise, for example A, I'll ask you right now, if I were to get rid of, or how would I change example A so that it doesn't have a vertical translation? And if you want to figure it out on your own, pause the video real quick, because I'm about to answer my own question. Last chance to pause the video. Alright, so if I got rid of the minus 1, then we would get rid of the k value, and we would have no vertical translation. There you go. Alright, so that is that. Let's look at another example. So where's the vertex? A quadratic function, y is equal to a function f of x, and is plotted on a graph, and the vertex of the resulting parabola is at the point 1, negative 3. Okay, so what is the vertex of a function defined as g of x, where g of x is equal to f of x minus 3? So right now we're not given the actual expression of the original parabola for f of x, but we can read the function notation to figure out what g of x looks like in relation to f of x. So we have a minus 3 tacked on at the end, so that's a k value. Our k value is negative 3. So the g of x looks like f of x, but 3 units shifted down. So we're going to take the vertex of f of x, subtract 3 from the y value, and we'll find that the vertex for g of x is the point 1, negative 6. All right, example B. We have a vertex of a function defined as h of x, and h of x is f of x plus 1 plus 5. So our h value is negative 1, shift left 1. Our k value is positive 5, so shift up 5. From our f of x function, so we take f of x, 1, negative 3. We're going to subtract 1 from the x value, and we're going to add 5 to the y value. So our vertex for h of x is the point 0, 2. 1 minus 1 is 0, and negative 3 plus 5 is 2. That's our answer. Last example, example C. We have another function h of x, and it is defined as f of x minus 3 plus 1. So that's a horizontal shift 3 to the right, and that's a vertical shift up 1. Or our h is 3 and our k is 1. So we're going to take our vertex for f, we're going to add 3 to the x value, and we're going to add 1 to the y value. The resulting vertex for our new parabola is the point 4, negative 2. That's our final answer. And what's great is we don't know what the parabola for f of x looks like, but we can figure out g of x and h of x. We can find their vertex in relation to the vertex of f of x, because we're given this function notation right here. So the key to this, and the reason why we do this exercise, is because we're practicing reading this function notation. All right, takeaways. We now know what a horizontal and vertical translation, what they each are, and we're building our skills in reading function notation, and we now know how to interpret translations using function notation. And that's it. Have a great weekend. Flamingo Fridays. Join the flock.